Good day, grade 8 Mahati Science High School students. For our 12th module, we're going to be reviewing about parallelograms. Okay, so let's start our problem with this question. So Christine, for her math project, wanted to create a sustainable plant vase for her aquaculture plants. To do so, she needed to drop a ramp-like figure given here below. So we need to find the area. We need to find the area of this parallelogram ramp that Christine has for her flower vase. So how are we going to solve this problem? Okay, so if we're going to look at this figure, this is a parallelogram. We can draw a right triangle here. Okay, we can draw a right angle. We can draw a right angle, and we formed a right triangle. Okay, so for this problem, we know that this is 15 inches. The hypotenuse is equal to 15 inches. And to solve for the height, we can solve for the height. Okay, okay, so we know that this is 20 inches as well. Okay, so we can solve for the height here by okay, so for this problem we have a hypotenuse here and we have a right angle. And this right angle created a right triangle. Since we know that TS is equal to 9 inches for this problem, and we have here 20 inches for SR, and the hypotenuse here is equal to 15 inches, so therefore we can solve for the height. We can solve for the height of the parallelogram. That's just going to be a squared plus b squared is equal to c squared. We're going to use the Pythagorean theorem. So therefore, that's going to give us a squared plus 9 squared is going to be equal to 15 squared. Therefore, a squared is equal to 15 squared minus 9 squared. And 15 squared minus 9 squared, that should just give us 144. And if we take the square root of both sides, we can get that the value of a is just equal to 12. Okay, so there you go. So therefore, our height is just equal to 12 for this problem. So therefore, if the formula for finding the area of a parallelogram is equal to base times height, so therefore the base, which is 20, and the height, which is 12, can be multiplied in order to get the area of the parallelogram. And therefore, that's just going to give us 240 squared inches. So therefore, the parallelogram ramp has an area of 240 squared inches using the Pythagorean theorem. And that's how we solved it.